Welcome back. In this video, I'll be discussing about the allocation table. Allocation table is a physically addressed metadata of ASM. In our previous video, we discussed about disk header and the partnership status table. In this video, we'll be discussing about the allocation table. We already know that block 0 of allocation unit 0 is reserved for disk header information. And similarly, the block 1 is reserved for free space table. We'll be discussing about free space table in our next video. And from block 2 to block 255 are reserved for allocation table. Every disk contains at least one allocation table. Allocation table has one entry for every allocation unit on the disk. Each allocation table block can hold information for 448 allocation units. So the allocation table has a total of 254 allocation table blocks. In allocation unit 0, we total have 256 blocks, and the block 0 is reserved for disk header and block 1 is reserved for free space table, and we are left with 254 blocks. So that means these 254 blocks are reserved for allocation table, and each block can contain information for 448 allocation units. So in this slide, we see that the first block of the allocation table has the information for the first 448 allocation units. So every allocation table block has the offset value equal to the first allocation unit that is addressed by this allocation table block. So in this slide, we can see that the offset value is 0, which means that the first allocation table block, that is the block 2 of the allocation table, addresses the first allocation unit 0. And in this slide, we can also see that the allocation unit 1 and the allocation unit 2 are already allocated to a file. So every allocation table entry has the extend number and the file number to which this allocation unit belongs, and the flag value where v equal to 0 or 1, which means that if the value is 1, it means that this allocation unit is already allocated to a file. If the value is 0, this allocation unit is free, and this allocation unit can be allocated for the files in future. In this slide, we can see that the offset value is 448, which means that the block 3 of allocation table, which addresses the first allocation unit 448, that means that the first allocation unit 448 is the allocation unit that is addressed by this block. And similarly, if you are looking at the 255 block of allocation table, the offset value is given as the allocation unit 113344 is the allocation unit which is first allocation unit that is addressed by this allocation table block. So in an allocation table, we have a 254 blocks, and each allocation table block can contain entries for 448 allocation units. So that means that with the 254 allocation table blocks, and each block can contain information for 448, which is nothing but 254 into 448, that is equal to 1,13,792 entries that can be accommodated in one allocation table. But what if we have a size, if we have a disk with a huge size? So in that case, we need multiple allocation tables. So one stride can be defined as 1,13,792 entries. So this called as one stride. For example, if we have an allocation unit size of 1 MB, then the stride size equal to 1,13,792. But what if we have an allocation unit of 4 MB size? So in that case, we'll be having more number of allocation table blocks, and the stride size would be equal to 4,54,272 entries. That means that one allocation table can contain information for 4,54,272 allocation units. A stride size is defined as the number of entries that can be accommodated in one allocation table. So we'll be discussing about these things in the next demo session. So we can find the stride size in the disk header for the value kfd_hdb.mfact. This value shows that the maximum stride size. And in this field, we can see that kf.b.au number equal to 0, which means that is the first allocation unit number that is addressed by that particular allocation table block. And if we have the allocation kf.b.au num equal to 448, it means that 448 is the first allocation unit that is addressed by that allocation table block. kf.b.shrink value defines the number of allocation units that are addressed by this AT block. If we have this value as 448, it means that this allocation table block can contain information for the 448 allocation units. So as we discuss, the allocation unit 0 can address for 1,13,792 entries of 1 MB allocation unit size. And the same time, if we have a 4 MB allocation unit size and our stride size is equal to 4,54,272. But if we have a huge disk which has more allocation units than that can be accommodated in one stride, so in that case, the next stride, the first allocation unit in the next stride has this allocation table and the free space table. So in the first allocation table, we can, with a size of 1 MB allocation unit, we can have a stride size as 1,13,792. So if we have a more allocation units than that, then the allocation unit 1113792 is the allocation unit that has the free space table and the allocation table in this allocation unit. And this allocation table block in this allocation unit number will have the information for other allocation units on the disk. I'll be showing about this in the demo, so that will give a clear picture. So this is how this block, the allocation unit number 113792, is the block which is formatted to store the information for allocation table and the free space table, which will be used for address the next allocation units. And this stride can contain information up to 2,27,583 allocation units. And if our disk is more than that, then we'll be having one more stride, which will be starting at 2,27,584, and this will go on. That's all about the allocation table. Thanks for watching this video.